this question, it is given O is the center of the circle, CB and AB are tangents, and the line CD is equal to the line AD. We need to prove that the line OB is parallel to the line EC. Before we start, let's see what we are given. We have the center, so we can use the first theorem that states a line from center that's perpendicular to the chord bisects the chord, or a line from center that bisects the chord is perpendicular to the chord. And we can also use the theorem that states the angle at the center is twice the angle at the circumference. In addition to that, we are also given two tangents, AB and BC. So we can use the party-head theorem or the tan-chord theorem. Now that we know what theorems we could potentially use, let's start answering the questions. In order to prove OB is parallel to EC, there's one of two theorems we could use. We could form an F shape by letting angle C2 equal to angle D2. This would be corresponding angles. Or alternatively, we could prove that angle C2 plus angle D1 are supplementary, meaning they equal to 180 degrees. This would be co-interior angles. Let's work with the corresponding angles. We can see that the line EOA would be the diameter of the circle, as it's a line that passes from one side of the circumference to the other and passes through the center of the circle. The line EA subtends angle C2 at the circumference, which would form a 90-degree angle. This is because the diameter always subtends a 90-degree angle at the circumference. Alternatively, you could think of it as this angle is 180 degrees at the center, and this angle at the circumference C2 has to be half of it. Thus, it is 90 degrees. So angle C2 equals to 90 degrees, and your reason would be angles in a semicircle. We now need to prove that angle D2 is 90 degrees as well. We can see that the line OB passes through the center, and the line AC is a chord. It is also given that the line OB bisects the chord CDA. As we have this T shape with the longer part of the T passing through the center, we can use the first theorem. The first theorem states that if a line passes through the center and it bisects a chord, then that line would be perpendicular to the chord, making angles D1 and D2 90 degrees. So angle D2 would equal to 90 degrees. And our reason would be line from center bisects chord. Therefore, the line EC is parallel to the line OB, and our reason would be the converse of corresponding angles. Remember, we need to state that it is the converse of corresponding angles, as generally we know the angles are equal and therefore the lines are parallel. However, in this case, we're proving the angles are equal to each other and therefore proving the lines are parallel. The second part of the question states, if B1 is equal to X, find E in terms of X. Now let's see, where's angle B1? Angle B1 lies in the triangle BAD. So let's see what other angles can we find around angle B1. We can prove that angle D3 is 90 degrees. We can do this by saying it is vertically opposite of angle D1, or using angles on a straight line, where angle D2 plus angle D3 needs to equal to 180 degrees. Let's use vertically opposite angles. Now we can calculate angle A2 using interior angles of a triangle. We know that angle A2 plus angle D3 plus angle B1 has to equal to 180 degrees. Our reason would be interior angles of a triangle are supplementary. So, angle A2 plus the 90 degrees of angle D3 plus x of B1 is equal to 180 degrees. And if we solve for angle A2, we get angle A2 to be 90 minus x. Now we can see angle A2 lies between a tangent and a chord, and within our circle we also have a triangle. This means we could use the tan-chord theorem. The tan-chord theorem states that the angle between a tangent and a chord is equal to the opposite interior angle. Now, how do we know which is the opposite interior angle? we use the jump in and run method. So angle A2, which is this angle over here, would equal to angle E2. Why? We jump over the line AC and then we run up the line AE. Thus, we know that the angle E is equal to the angle A2, which is equal to 90 minus X degrees. And our reason would be 10 chord.